Hi, hello. We will now try to solve this particular problem on projectile, and this is about a cannon firing a projectile from point A. That's the so-called point of launch or the launching point, and of course it will travel through a trajectory known as a parabola. Now, let's say we have a target at point B right there, which is 2,000 feet above, vertically above point A or the launching point, and 12,000 feet to the right, horizontally to the right of the same launching point. Now, the secret actually in dealing with this type of problem is you need to separate the solution for each of the two components, which is for HM or horizontal motion, which is a uniform rectilinear type of motion. And the only functional equation out of the three is this second equation for kinematics. Now, since the motion is URM, then acceleration is, alright, 0. And therefore, that will make our equation simply equal to the displacement equal to the product of the initial velocity and the time. Alright, the horizontal, since this is about horizontal motion, the equation becomes horizontal displacement is equal to the initial velocity along the horizontal axis times the time. Alright, now since again this is about horizontal motion, then we need to see to it that all the variables involved there are the so-called horizontal components, just like your initial velocity. So your initial velocity must be the x component of the initial velocity. If we refer it back to our figure, that's our v sub ox, which is adjacent to theta. Therefore, v sub o is equal to v sub ox, or 800 being the initial velocity, times the cosine of theta, which is our unknown. Alright, so now that we know v sub o, what about t? Now, talking about time, by the way, time will be common for both of the motions. I'm referring to the both horizontal and the vertical motions. Now, another given in this particular formula is of course the value of the horizontal displacement. Looking back at our figure, we can clearly see that the location, horizontal location of our given position, which is the target in this case, is 12,000 feet from point A. So that will comprise our horizontal displacement. Alright, and then substituting all these known values to our formula, we will come up with, and that's 12,000 equal to the product of 800, the cosine of theta, and of course, the time. Simplifying, now, you can see clearly that there will be two unknowns in just one equation. So we are anticipating already that we will be dealing with several equations in several unknowns. So the method I have chosen, of course, is the method I am developing, and my preparation, of course, since we are after theta, is this equation, and let this be equation number 1. Alright, so this is all about the first part of this video for the solution of this problem on projectile. This is our solution for or under or when we consider only horizontal motion, and we will definitely get only one equation. So watch out for the second video, which will be dealing with the other solution, which is for vertical motion or VM. Thank you.